All right, good morning, everybody, to this. What day is it? Oh, Friday. To this happy Friday. Yay. Where we are simply continuing our um, exploration of some general problem solving strategies, seeing some examples to get that experience that we need. As always, can someone just confirm in chat that they can both see and hear me, and then we can get going.
Yeah.
All right. So I asked at the end last time that you put like 5 minutes of effort into exercise 3.5 without looking and getting any help, essentially cheating, because a question like this, uh, once you see the answer, there's nothing more to learn. So hopefully you did that for exercise 3.5. Let's just read it together. An array of 9 dots is arranged in a 3 by 3 square as shown at the right, actually below. Is it possible to join the dots with exactly 4 straight line segments? If you are not allowed to pick up your pencil from the paper and you may not trace over a segment that has already been drawn, you can cross them, but you can't go on the same line in the same direction. If so, show how. Now, if you happen to be watching this on a recorded video after the fact and you have not tried this yet, pause here and try it. I'd say just take like 3 to 5 minutes because even that, just spending time with it, just looking at it, just thinking, it makes a difference, even if you don't get it at the end. That effort, that time that you invest, still uh, pays off, even if it doesn't feel like it. So let me just clarify here with my dots. 1, 2, 3. Let's try and space them out nicely here. Now they are asking for uh, 4 straight line segments. But let's just make it easier. Can we do it with 5 straight line segments? 5, hopefully you would agree, is not a problem. Oh, I can't speak and draw the line for some weird reason, or I just can't draw the line at all. What's wrong with my line tool? There's a line. Let's put it on the dots. Okay, there's 1, 2, 3, 4, and 5. Super easy with 5 lines, right? And there are many other options, of course. I just did it like this. So many. The challenge, as I go back here, is to do it with 4 lines. Now, again, if you haven't thought about this, well, that's too bad. But if you're watching a recording, definitely do pause and uh, think about it. And it highlights a very important thing that I do without realizing it in problems in general. So 4 lines could look like this. That's 1, that's 2, 3. It's going through that dot. My angle's just off. Oh, no. My line drawing tool does not want to play with me. Last one should start at the top left. It's connecting, right? So yeah, my dots are a little out of place. That's why they're not perfectly going through here. So it is possible to draw it with 4 lines, and it could look like this. And it shows something very important, that sometimes people see this answer like, well, you're not allowed to go outside of the box. You go further past the dots and then turn around. Why can you do that? And it shows how quickly and easily I bring my own assumptions into a question. It didn't say I'm confined to this square area or anything. It simply says that you have to connect four straight line segments and don't double back on a line you've already drawn. That's all it says. But so easily, myself included, we tend to bring our own assumptions and it limits us and it could prevent us from even answering the question that this is not possible if I stay within my four my square area. I can't do it with four lines. I have to go outside and turn back in. And that's perfectly valid, even though I so quickly exclude those possibilities, adding stuff to the question that it didn't say any other restriction. So it's very important to be aware of things like that. This isn't a test question, but it does show uh, something very important that I can take with me, that I can add to my experience. All right. So let's see. We did leave out 3.4 on purpose, and we haven't skipped anything else. So I'll come back to 3.4. It's just little out of place. I need to reposition it, but what does it matter? Okay. So I don't know if I call it a strategy, but it's definitely something that I need from experience going into any question. And I see it so often in elementary school as well, where things are difficult, things are new. It's hard for kids to learn something that we might think is basic. It's brand new to them. It's so important to ask smaller, easier questions first that can help me get towards the answer. For example, this is just a random example I happened to see a couple of days ago. In a grade 4 class, uh, the question was just a random example from my experience. Um, how, I'll just do it short in a short way. How many $100 bills does it take to make $9,000? Okay, random question. It was a homework question. Grade 4. And to us, it seems so incredibly simple, of course, because we have a ton of experience in arithmetic. They don't. So now, when this, if this is easy for a student, great. But when it's not, what can you do? When this feels overwhelming, hard to imagine, but definitely for some, this feels overwhelming because in their journey, this is a challenging question. And what doesn't come natural is instead of this question, just ask a different question. Ask a smaller, easier question. Like the one I suggested was how many, well, I struggle to write today, how many $100 bills does it take to make, let's just take 1,000. And that's remarkably uh, easy in comparison because they can count in hundreds, they can get to 1,000. It's not that far out of reach. But getting into that habit of asking simpler, related questions first. Now, the irony is that my attempts were not successful because it felt to the student as if they, instead of just having one question to do, I now keep asking them brand new questions. And now suddenly their homework of one question becomes three, four, five questions. And they didn't understand. Why do they have to answer so many questions? They just had one to do. So it shows how not unnatural, how it doesn't come naturally to just say, let's just put a pin in the question and ask questions that I can handle. Smaller questions, maybe many, but with each question, I'm getting closer to my ultimate, to answering my ultimate question. that it feels as if I'm doing so much more work. That can't be right. But I'll do whatever it takes to get to the answer. If I have to ask 10 questions on the way to my ultimate problem, then I'm going to do that if that's what it takes. And that's not something that people tend to do. They don't want to make more work for themselves. It feels very counterintuitive for a little elementary school student, perhaps. But sometimes it's necessary for me to just understand the question. Now, we'll make it a little bit more challenging with exercise 3.6, but the idea is the same. Now, perhaps you've seen this kind of question before. Then, once you've seen it once, the mystery is a little bit less, but maybe you still get something out of it. We want to arrange the numbers 1 through 9 into a square that's subdivided into 9 smaller squares. Let me just make the picture so it's easier for you to see in case you're not sure. Whoa, that is not straight. Like that. 3 by 3 grid. Whoops, can't speak and draw apparently. Come on, man. Like so. So that's our layout. And we want to fill the numbers 1 through 9 in so that the number of every row, every column, every diagonal, not just the main one, is the same when I add them up. The sum of every row gives me the same answer as every column, as every diagonal. This is called a magic square. So, of course, first thing is to understand what the question is asking me to ultimately do. Let me just check because it's extremely quiet. I understand it's Friday, but I just want to check if everyone understands the question. How we're going to do it, what the answer is, that's not the issue. That is not the problem right now. Understanding is step one. How do we feel on this lovely Friday?
Feels good.
Feels good.
Okay. And if you don't understand the question, we definitely interrupt me because we can't make sense of the next part if we don't understand the question, right? We don't want to assume anything or anything. Okay. So now, of course, I don't think it's overly challenging to understand what I ultimately want to get. The question is, how do I go about doing it? Do I just randomly write numbers in? What do I not have yet? 7, 4, 6 is missing. There you go. Do I just randomly fill it in and hope for the best? Well, if you're extremely lucky, go for it. But now I see that if I add these up, I get a 10. If I add these up, oh no, that's 20, isn't it? Add these up, that's 15. So that's not the right answer. They need to all add up to the same thing. So people's tendency then is to try and tweak this. Okay, let's swap some numbers until I maybe get to the answer. That's going to take forever. And I might never get there because I might keep swapping the wrong thing. I need a plan. I need a plan because randomly putting stuff in and tweaking them does not fill me with any sort of confidence. And for that reason, people uh, find magic squares to be very confusing. But if I can just slowly work my way towards the answer, every little step I make, every little question I ask myself, getting me closer, well, then I'm not going to be concerned at all because it's just a matter of time then. The question is, how do I approach this in a more systematic, progressive way? Well, the big clue and the big thing here is that every row, every column, every diagonal has to add up to the same thing. With experience, the obvious question immediately becomes, what is that answer that they add up to? That's apparently the same for every one of them. So instead of answering the question, where are the numbers? I'm going to ask another question first. What is this total for ah, each row, column, diagonal, squeezing in a question mark? They're all adding up to the same thing. What is that? So I want to know, if I add up all these rows, I'm going to get a number. Let's call it question mark. That question mark is going to be the same answer I get when I add the second row, third row. This column is going to give me the same number. This column is going to give me the same number. This one's going to give me the same number. And the diagonals. Okay, now it gets overwhelming. What if I just focus on the rows? Let's just do the rows. Okay. Now, I don't know where the numbers go, but let's notice something. That considering all the rows, man, my writing is terrible today. Considering all the rows, we are, let's say, we're using each number, 1 to 9. They're somewhere in here. I don't know where they are. They're somewhere. But by looking at the first row, second row, third row, I'm using each of those exactly once. Wherever the 1 may be, it's only in one of these rows, which is why I don't want to double it up with columns as well. Okay, so first row gives me a question mark. Let's put it in a box. Let's put it in a box. That's my symbol for the answer, which I don't know what it is. Second row also gives me question mark in a box. Third row also gives me question mark in a box. And I'm trying to go slow enough to make sure everyone is sort of following how we're doing this. I don't see any expressions or reactions, so I have to guess how fast I need to go. If I add up all of these, not with a line space, thank you button. If I add up all of these, my total is 3 question marks in a box. But observing that in doing that, I have just counted every number in a specific way, row by row. I should also get this by individually adding up all the numbers. 4, 5, 6, 7, squeeze it in. So I can get that total in 2 different ways. In the one way, I'm looking at one row at a time. I just don't know where the numbers are. And the other way, regardless of where the numbers are, I could just pick them separately and add them up. These two have to be the same answer. Now the left side, I see all the numbers and I can add them up one by one by one. What do I get when I add up 1 through 9? You can do it one by one. You can do whatever you want. Calculator, I don't care. 45. So overall, that means 3 times this mystery question mark in a box is 45, which means that a single question mark in a box value is 15, which means that each row adds up to 15. Each column has to add up to 15. Each diagonal has to add up to 15. But now I have much more information than I did starting out, that I know exactly my target value, my target little answer for each row, each column, diagonal, and so on. And knowing the 15 is the key number, I've taken a big step towards figuring out which number goes where. But first, let's pause, because this is probably one of the, maybe the most difficult of all our examples, I would say, the magic square. So I want to have a pause and check whether this makes sense in how we got the 15. We're just gathering the numbers 1 through 9 in two different ways, individually on the left or row by row on the right. Those two have to be the same. How do we feel so far?
Makes sense.
All right. Now, I know almost for a fact that some people are extremely confused right now because it happens every semester. This wouldn't be any different. Whether it's now or later or whenever you want to watch the video again, you want to do something, it's okay. But if you are confused, you need to bring it up. I can't guess. Okay. So now I want to just leave this. I'm going to just make a new page instead of scrolling up and down. My square is a little messy, so I'm just going to make a new clean one. Well, I'll do it eventually, not right now. Now, I need to work with this 15. This is now my new information. And I know that a row consists of 3 numbers, a column consists of 3 numbers, a diagonal consists of 3 numbers. So somehow there are different combinations of 3 numbers that when I add them up, I need to get to 15. So let's just see all the different ways that we can add 3 numbers and get 15. I know I have to get 15. Let's say here, combinations to add up to 15. That's my next task. So I'm asking smaller questions. First question is, what is that total? That is apparently the same for all of them. It's 15. Next question, well, okay, how can I break up the 15 in different combinations of 3 numbers? Of course, 1 to 9. Maybe it's going to help me if I can see that list. But now, again, making a list is not going to be random because I will have zero confidence that I'm going to get them all. So I have to be structured in how I make my list. Out of habit, I go increasing order. So again, I'm going to fix the first number as a 1, and then I'm going to fix the second number as the next one in line and see, is there anything here that'll give me 15? That was a question. Is there anything there that can give me 15 as the third number?
No.
No, because it's going to have to be a 12, and I can only use numbers 1 through 9, right? Okay, so that's out. That's fine. It's not a problem. I'm not going to write the equal 15 every time. That's always our target. So then I have to go and say, okay, well, the 2 was too small. So let's update that to 3. No, that's 4, so I'm going to need 11. That's not going to work. Next one is going to be 4. That gives me 5 so far, and I don't have a 10, so that's not going to work either. But I'm still working my way systematically through these, right? Let's try a 5. That gives me 6 in total. The third number will have to be a 9. So that's definitely one of the combinations. Then I'll try and keep the 1 for as long as I can. Then update the second number to the next one in line, which is a 6. That gives me 7 so far. An 8 would get me to 15. Try and keep the 1 so that I reduce it to a smaller combination. Next one in line is 7. That would make the third number. I'm pausing so you can say something. Nothing? Okay. 7. But I only have one 7, so that's not going to be allowed. Okay, so it can't be a 7 in this case. So then I go to my next digit, which is an 8. But then I would have to have the third one a 6, and I already have it there. There's no need to double up. I'm not looking at an arrangement. I'm just looking at the groups of 3 numbers that would get me to 15. So I don't need to double up on these at all. Same thing here. If I have a 9, then I would just get the first one. And I've gone through all of the possibilities. Oops, like that. All of the possibilities starting with a 1, which means I need to update that to a 2. But it's very important to have a plan of working through this. So within this magic square question, there are smaller problems that I need to address. And with each one, it gets me closer and closer to my ultimate question. But it's a big one. This is a big one. And I don't know that going in. It just is what it is. So starting with a 2, there's no need to go down to a 1, right? Because I would have seen that when I started with a 1 already, which means I only need to go higher. So the next one is a 3. But that gives me 5, so I would need a 10, and that's not going to work. So I go 4. 2 plus 4 is 6. So the next one would be a 9, which is a new combination that I don't have yet. Stick with a 2, then go up to my next second number. So now I have a 7, and the next one would be an 8 to complete it. Then go to a 6 for my second number. That gives me 8 so far. 7 would complete that. Do I need to go to 7 for the second number? No, because then I just get this one back. 2 plus 8 would just get that one back. 2 plus 9 would just get that one. So I'm done. Well, rather, I'm done with starting with a 2. All right, so let's write the others alongside it. I don't know how many I need. I don't know how many I'm going to get, right? But I know that if I do this systematically, when I'm done searching through all the possibilities, I'm done with confidence. So now I'll start with a 3 because I've done everything I could starting with a 2. Starting with a 3, I remember I only go up, so 3 plus 4 is 7, and then an 8 would finish that. 3 plus 5 is an 8, 7 would finish that. 3 plus 6 is a 9, and then another 6. That's not going to work, right? I can't have two sixes. There's only space for one number. 3 plus 7 will give me this one. 3 plus 8 will give me that one. 3 plus 9 is 12, and then another 3, and that's not going to work either. So it seems like I have gone through all the possibilities that can start, all the new ones that can start with 3. Back here. That means my next one that I need to consider starts with 4. I only go up, so 4 plus 5 is 9. I can finish that with a 6. 4 plus 6 will just get me that one back. 4 plus 7 will be 11, and then I would need a 4. I only have one 4, so that doesn't work. 4 plus 8 I already have. 4 plus 9 I already have. So those are all the options, starting all the new ones, starting with a 4. Hopefully this makes sense. No one is saying anything, so that is up to you. Starting with a 4, I've done all the new ones that I haven't covered yet. Starting with a 5, I only go up. 5 plus 6 I have there. Okay, so that's out. 5 plus 7 I have here. 5 plus 8 I have there. 5 plus 9 I already have as well. So that looks like all of them. Yeah. So the further I go, the fewer new ones I have because I don't care about the arrangement. That's a 5, right? So 6 is next. 6. All right. 6 plus 7. I already have it. It's over here. 6 plus 8. I already have there. 6 plus 9 is not going to work because I'll show you. 6 plus 9 is 15 and then 0. There is no 0. So those are all the possibilities that start with a 6. And I'm running out of options really. 7. 7 plus 8 is already 15. 7 plus 9 is too much. So 7 can't have any new ones. 8 plus 9. No, I'm done. That's it. But it's important that you are happy that that list is complete. I don't need to be happy. I'm convinced. But it's important to do it in a way that convinces you. Now, this might not be the way you want, as long as you have a structured, systematic way of doing it. Any questions at this stage? Because this is such a big question, I need to just pause and check often.
Yeah, so far so good.
It's a big
usually
one.
things come around.
Yeah, it's a big one. Okay, so now I've made my list. Where am I now? Let's reevaluate here where we're at. We figured out the total. We've used that to see, okay, how can I break it up into 3 numbers that give me that total? Here they are. Now the only question really is, where do they go? Let's make a square over here maybe. Like so. My other square was a little busy. Let's do it over here. So now within that, I'm getting closer, definitely, but I'm not there yet. Every time I'm asking myself a more manageable, easier question. Started out with, what is that total that they refer to? Figured it out. Then, instead of putting in the numbers, how can I get that 15? Now I have that. Now I have to eventually ask, well, where are these guys going to go? But then I notice that if I look at this top left, for example, in how many different combinations does that feature? It's going to feature when I add up the first row. It's going to feature when I add up the first column and then diagonal. So it's going to feature in 3 different occurrences in my list. But that's not the same for all numbers. Look at this guy. That one features in the first row and the second column, only twice. So is there a little square that is different from the rest in terms of the number of times it's going to feature?
The center one.
The center one is going to feature more often, right? It has a row, it has a column, diagonal, all kinds of stuff. So whatever goes in the center has to be the number that features in most of the combinations, or features in combinations most often, rather. Which number, 1 through 9, features the most?
5.
It's a 5. It has to be a 5 in the center. So it's not as if I now just try and arrange these combinations in my square. There's still a smaller step I can take. So now I know, oh, that center one has to be a 5. Okay. So now the combinations surrounding that 5, I'm now limited to this one, this one, this one. Feels like I'm missing one. Why do I feel like I'm missing one? I don't know. Maybe not. Maybe it's just me. Okay. Really feels like I'm missing one. It's just paranoia. Okay. So let's maybe look at this guy, this top square. That guy we said only features in 2 of the combinations. When I do the top row and when I do the center column. So it's going to be paired with a 5 and feature only one other time. These arrows are now a little deceptive here. While you're looking for that number, I'll erase some arrows. What could be the one in that top center position?
3.
Can it be a 3? Well, 3 is paired with 5 and occurs only one other time. So let me erase my circle because it's not going to be the most important square when we're done with it. 3 would definitely be a contender. I'm not saying it's the only one because this square also has that property, right? So there could be multiple ones. I just picked the one that she said, whichever one comes to mind first. That means that I have to have a column 3, 5, 7. Now, you might have picked something other than 3. You might have picked the 7 or something else. Then yours might be a flipped around version of the square we're going to get. There isn't just one. I can flip it and rotate it, but they're all equivalent. Okay, this is just one of those versions. So now also the 3 is combined with the 4 and the 8, and I can put them wherever. If you put them the other way around, then it's just the horizontally flipped version of the same square. Doesn't matter, right? So there's no harm in just putting them in wherever. So now I have maybe a 4 and a 5 I want to look at. That means that the 6 has to be in the bottom here. So to complete that diagonal, right? It has to be 4, 5, and 6. You can maybe finish the other diagonal, 8, 5, and where is it? Over here. 8, 5, and 2. Completing 2, 7, and 6 as well. And things go very quickly now. 4, 2, and 9 is over here. 9, 5, and 1. And then I can check 8, 1, and 6 was the missing one. And I am done. Victory. But it was a journey. It was a test of patience, perhaps, that with every step I take, I'm getting closer to the answer. Does it matter how many steps? No, it's really how many steps I need. But the steps have to be manageable for my experience level, for my abilities, what I can handle. For someone, I can take bigger steps because they've seen these things before, for whatever reason. Someone else, even if it's a simpler question, they need many little steps to have them be convinced of the answer that they can eventually get. But it's just a matter of time. That doesn't bother me. I have to take steps according to what the question needs. Some questions will be super simple. Some questions like this one will be more involved. And then, of course, I have to scale my uh, strategy accordingly. All right. Magic squares. And it's not really about the magic squares, it's about the strategy involved and what I can learn from this question. Asking smaller questions first. Let's do 3.7. Why not? It's next in line. Some people get very confused with this question. Hmm, not sure why. Maybe because it's coming off of 3.6, which was a big question, so now they think, oh, this is going to be a worse question. No, not necessarily. It is what it is. Let's give it a chance. A certain convention numbered 100 politicians. Each politician was either crooked or honest. We're given the following two facts. At least one of the politicians was honest. Given any two politicians, at least one of the two was crooked. Can I figure out how many were honest, how many were crooked, and what are those numbers? Again, some people, especially with this kind of question, some people have a very good uh, intuition. It's not really intuition, it's kind of experience. And some people don't, and that's okay. Let us see what we can do. And even if I know the answer and I'm convinced I know the answer, can I explain it to someone that doesn't see it like I do? So it's not just about knowing the answer, it's about being able to explain or teach someone else to be convinced of the answer that you may or may not see. Or if you don't see it, then I have to have a strategy to figure it out. Okay, so I have 100 politicians. What are my options really? What are the options here for the breakdown of honest versus crooked? Let's say honest versus crooked. They have to add up to 100. So it could be I can have, let me just see which order I want to do this in. Which one do I want to start here? It doesn't matter. I can have maybe let's start optimistic. I can have 100 crooked, honest, 100 honest politicians, zero crooked, right? Or I can have 99 and 1, 98 and 2. And slowly it shifts over. I am just going to use some dots. I don't want to list them all. Maybe let's go 3 and 97, 2, 98, 1, 99, 0, and 100. The option has to be one of these rows, right? There can't be any other option because I have 100 politicians. Okay, so that's maybe a way to give me something to look at, something to think about, something to work with. Now I ask, it's not going to be as bad as going through each of these individually. Once I start seeing a recurring argument, then I can definitely skip some. But I need to start somewhere. Can I have 100 honest and 0 crooked? Well, I know there is a honest politician, so I definitely need to have one or more. I happen to have 100. Can I have 100 honest politicians and 0 crooked? It's very quiet. Is it because it's Friday or because it's too easy or too difficult? No, no reaction. Okay. Well, the first fact certainly is true. It's consistent. At least one politician was honest. That means one or more. But the second fact is a problem. Given any two politicians, at least one of them has to be crooked. And I have no crooked ones at all. So that's going to be a no. Because if I randomly take two politicians, they're both going to be honest. There's not going to be a crooked one in there at all. So it can't be 199, as much as I would love that to be the case. So I move on. Can it be 99 and 1? Well, I definitely have an honest 1, which the first fact says I need. I need one honest politician or more. But the second one is if I take any two politicians, among those two must be one or more crooked. Now, if I have a circle, there's 99 politicians floating around over here that are honest and a little one guy. Sure, if I take one of these and one honest one, then I'll have a crooked politician among the two selected. But I have but I have to be able to take any two. So I could take two of the honest ones, and then that fact is not true. It's the any. If I take any two politicians, among those, someone must be crooked. I could take two honest ones, and then I won't have that fact be true. So then I continue to the next one. And with 98 and 2 is still an issue. Sure, I have more crooked politicians. And if I select my 2 from some of these crooked ones, then that fact will be true. But it's any 2 politicians. I can select within this honest circle 2 politicians, and then the fact is not true. I won't have a crooked politician. So that's going to be a no as well. And I can now keep going. Did I not erase this? There we go. I can keep going and going and going. That as long as I have multiple honest politicians, it's all going to be a no. If I have the 2 one, for example, I only have these 2, and I have many other ones here that are crooked. Sure, if I select my pair of politicians from some crooked ones, the second fact will be true. But I have to be able to select any 2, and that fact must be true. I can select the 2 honest ones. Then I don't have a crooked one among them. So that's not possible either. Let's skip this one over here and go to the 0 one. The 0 case with no honest politicians can't happen, right? Because the first fact isn't true anymore. I have to have at least one honest politician. So that is a no as well. Okay, so that's out. Now the only one left is exactly one honest politician. There they are. Exactly 99 crooked politicians. Now, if I want to select 2 politicians, I'm going to have to, even if I select the honest one, I'm going to have to select from the crooked list as well. And I'm guaranteed to have at least one crooked politician. Or maybe I select both crooked. I still have at least one crooked. So that is the answer. But I'm doing it in a way that I can defend my answer. I can explain my answer. I can write some stuff. I can do something to help clarify and maybe teach someone else. Now, many people get confused with this one. Think about it, sleep on it, watch the video again, walk through the argument, and let me know if you have any questions. All right, that's all the time we have, unfortunately. What you can do in the meantime is look at exercise 3.8 and actually just 3.8. You can look at 3.9 as well. Uh, these are not test questions. They're just nice questions to see that sometimes questions are just mean and they try and be confusing and they try and be tricky, and there's nothing really outside of that. They're just sort of novelty examples that are sometimes silly and frustrating to have. I don't even want them to exist, but trick questions do exist and they're there to create frustration and confusion and nothing more. It's nice to see them. Think about, some people enjoy thinking about them, some people don't. I list them to be aware that these exist and I can watch out for it, but it's not something that really makes me better much. Gives and adds to my experience in a significant way. So those are really just for fun. Let me know if you are confused or want to discuss them further. And next time we will start with some classic problems. All right. Thank you for being so chatty. I tried to fit my words in where there was a gap, and hopefully you've looked at some of these over the weekend and things slowly are getting better. Until Monday, then.